All right, so when organic students show up to organic chemistry, there's a bit of a culture shock, particularly if you work in, or you're going to school at a place that actually lets you go with the organic glassware. So let's take a minute to actually go through the organic kitware, and let's talk about how this is going to be kind of different than what you're used to seeing in terms of a general chemistry course. So glassware you're probably already familiar with: flask, beaker, watch glass. These are things that show up a lot in general chemistry, and we like to work with them because, well, they're cheap for one, and two, they've got flat bottoms, and because they have flat bottoms, they can sit on the bench carefully. So when you open up your organic kit, first thing you're going to notice is that you don't actually have any flat glassware. What you have are what are called round bottom flasks. So why do we work with a round bottom flask in organic chemistry and not your traditional beaker? Well, the reason is efficiency. This has the best surface to volume ratio. So when we stick this in specialized heaters, we actually get much better, much more even heating and much quicker heating, because all the heat's going in through all the edges and not just coming in through the bottom. We also kind of eliminate a lot of these heat transfer issues as well. So in your traditional organic chemistry kit, you have a whole bunch of different size flasks. So in this case, for our course, we got something as big as a 250, and we drop all the way down to a 25 ml when we get done to the smaller end. So why do we have the different sizes? Well, it depends on what you're doing with it. Typically, we don't want the volume of whatever we're working with to exceed half the volume of the container. So if we're working with 100 mLs of solution, we'd want to stick to the 250 ml volumetric flask, whereas if we're receiving something as little as 5 or 10 milliliters, we work with something like a 25 ml round bottom flask. Now, another thing to know about these flasks, and you can see this on a lot of this glassware, is we have what's called ground glass fittings. Now, the idea with a ground glass fitting is that if we have two pieces of glassware, so we have, this is considered a female, and this is a male fitting, these two will actually stick together. Now, because they will stick together, we have to use grease to keep them from seizing. Now, an exception to this is going to be something like a separatory flask, where we need to be able to get it on and off pretty quickly, and we also don't want the grease dissolving back into whatever we're working with. But if we have stationary glassware, basically we're setting up and we're running reaction, we're going to put grease on these fittings, and to do that, one of the most useful things we have in the organic kit is a grease syringe. So what the grease syringe does is allows us to put out a controlled amount of grease. And what I see a lot of students do when they first get to the organic class and they start putting grease in there is they start like globbing it on there. So if I want to connect two pieces of glass, all I'm going to do is take a little bit and put a little dab. If I can do it on the male fittings, if not, I'll do it inside the female fittings. That's really all you need. And the mistake here is thinking that you need a whole bunch, because what we're doing is we're creating micrometers of gap between the two pieces of glassware. And you can see here where I've got this nice thin grease layer. And I want to make sure it doesn't go all the way down, because if I have any type of splash up in this flask, it's going to catch the grease. But if there's a little bit of a gap there in the grease line, it means that I don't have to worry about any solvent kind of like taking the grease off. But this is how we connect the two pieces of glassware. Now, the other thing we're going to use is what's called a Ket clip. So a Ket clip, you've got the female end and the male end. The fat part of the Ket clip goes on the female part, thin part goes on the male part, and what it does is it makes it really hard for your pieces of glassware to separate, but they can separate just a few millimeters. And the idea with a Ket clip is that it will support the glassware. So if I hold this, it won't go anywhere. But if the flask or the chamber were to overpressurize, they'll separate enough that I can get airflow around the fittings, so I don't have to worry about the glassware exploding. Now, to get this grease off, if you're working with just a cheap grease like we do, you would use something like acetone. If you have something more expensive like a teflon or a silicone grease, you may need to work with something like methylene chloride to get the grease off. And this is a major limitation of the organic glassware, is that if we want to pour anything out of here, typically what we're going to have to do is clean the grease off before we do anything. So what else do I have in here? Well, I've got a separatory funnel. Well, this is technically a dropper funnel. So a dropper funnel has the glass fitting, and the idea with the dropper funnel is that we'll attach to another piece of glass fitting, and if we want to do a closed system, so let's say we want to put a flask down here, we can use this to control how much liquid gets dropped into the flask beneath it. So we can tell this is different than a separatory funnel because of this glass fitting at the very bottom. So something like a separatory funnel doesn't have the little fitting at the bottom, so it isn't designed to plug into other glassware. Now, can you use this as a separatory funnel? Yes. The major limitation here is that this separatory funnel has a very thin tip on the end, which is meant to control where the liquid goes. That isn't true in this case. You're actually going to get the liquid kind of going around all the edges on the inside. Also in here, glass stoppers. And these are surprisingly expensive. When I went to go look to additional ones to replace the ones we have in these kits, they're like 50 or 60 bucks a piece, which is ridiculous because this has to be the least technical part of these kits. But we have glass stoppers, and again, the idea with glass stoppers, they're designed to fit in and form a seawater glassware. This is what's called a Claisen Head. So the idea with a Claisen Head is that if we're doing a special type of distillations, and these will show up when you start doing distillations, the idea is that the Claisen Head is going to attach to our Distillation Head, and we can put like a dropper funnel here. So if we're doing something like steam distillation, we put the dropper funnel here to add more water if we start consuming it when we're doing the steam distillation. And then our Distillation Head receives two things, either what we're distilling or a Claisen Head, our thermometer adapter. So with your thermometer adapter, plugs into the top, there's a rubber, it'll either be red or black fitting. Thermometer slips inside the top, and when it comes to the thermometer, we're going to push it down until it's right at the opening of our sidearm. And then we have this other side which is designed to receive our condenser column. So our condenser column looks like this, and it's actually got 4 ports on it. So 2 ports, male and female, are for connecting to one to our distillation head and the other 2 are vacuum distillation attachment. We should get to that in just a minute. The other 2 are these side ports that are for receiving water. So when it comes to receiving water, typically what we do is we hook a hose to each end. One end connects to the sink, the other drains into the sink. And the one we want to connect to the sink is actually the one that is furthest away from whatever we're distilling. The idea being that we want countercurrent cooling, and that will maximize the temperature difference of the gases coming across. So this is your condenser column. We also have, this is technically a pack column. I'm going to defend that to the bitter end, but it's called a fractionating column by chemists. The idea is that when we do distillation, this actually stands vertically and it connects to whatever we're distilling. So we'd have a round bottom down here, we'd have our Claisen head or our distillation head up here, and this is just here to generate a lot of surface area for improving distillation. The last piece of glassware I have in this equipment, in this kit, is the vacuum sidearm receiver. What it's designed to do, one end will attach to my condenser column. One end is designed to connect to any type of receiving flask, and this little end here is meant that if we want to do some type of vacuum assisted distillation, what we do is we attach a rubber hose. We could hook it to a water aspirator or a vacuum pump, and this will allow us to draw vacuum. So those are all the components that go into your organic lab kit. And this is going to be specialized glassware. It's designed specifically for organic synthesis. But again, we use it because of its utility. It's much better than your general chemistry stuff, but it's also more expensive.